Okay, I guess we can get started. I had a teacher once who told me, before you want to do something, you always have to do something else. And this is something I've always taken to heart. And over the years, I've really come to understand what that means, because you start with an idea of something, and inevitably you come to having to make something else before you get to that idea. And quite often it's a regressive process of making something and then realizing you have to make something before that, and before that, and before that. So it becomes sort of a long chain reaction of things that need to get made. So my name is Robert Shepard. I like to make stuff. I'm a member of Makerversity, and I've said that's just over there. Makerversity, if you don't know what it is, it's a fabrication environment. It gives access to new technologies like 3D printers, computer-controlled CNC machines, and my favorite tool is a laser cutter. I use it almost exclusively. While working at Makerversity and at various fab labs over the past 5 years, I've encountered a lot of people who get stuck in the middle of their projects. So they start with an idea, but they're not able to finish it, or they reach a point that's somewhat impassable. I usually find that this is because of a few things. One, an incomplete idea of what they're trying to achieve. So they have some idea, and I had a discussion with somebody about this today. It was something like, if you wanted to make a chair, but don't really specify what kind of chair you want or what its goal is, it's easy to make something to sit on. You know, I could put a piece of paper down and say, okay, there's a chair, you can sit on it. But that doesn't really achieve potentially their goal. So the more you refine your goal, the clearer it is, the easier it is to make. And that seems somewhat obvious, but when you get into very specific kind of ideas, it becomes much less so. Another reason why people are not able to achieve their goal is because they're not really familiar with the materials. I mean, they have an idea that it's wood or plastic or something like that, but they don't necessarily know all the details of the specifics of things that are important to whether it melts at this temperature, whether you can use this machine with it, or how to actually fabricate it. And that you can usually be resolved by doing enough research, working on what standard sizes are, how flexible it is, what strength it has, etc. Another thing that people quite often get lost in is the unfamiliar with their tools. They don't really know the tools that at hand necessarily. So software, which can be very difficult, the hardware, the best practices for using those tools, etc. And I've come across that a lot with the laser cutter, especially because our laser cutter has somewhat buggy software that if you don't use, let's say, in an easy way, that you can actually end up with a lot of difficulties. Another thing is not enough efficiency planning or no pre-plan to iterate. So the idea is that they could make something and that they think that it will be perfect from the first time they make it. They don't anticipate that they'll want to make many copies of it or that they'll be able to refine it. So if you start with what you think is the end result, you don't necessarily ever look further than that end result. And I think the last thing is something that's a little bit more vague, but I call this sort of thought experimenting. So when you try and wrap your mind around the problem and you re-question alternative ways and to do something and whatever your goal really is. So Einstein used to do this with his light and thought experiments. If you're standing on a light beam and you shine a light at a speed of light, how fast does the photon go when you're going at the speed of light, etc. But I think you can take that sort of thought experiment idea and translate it into making things as well. What is it you want to make? What is it that, how can you refine it? So to sort of give you a practical example of this, I'd like to take you through one of the projects that I did over the past couple of months, and the problems I encountered and how I learned to deal with them. And I found that each successive project I do teaches me something new about how to approach my next project and refines my methods of creating. And that's pretty much what I want to share with you now. So the project I had, it starts with a kind of challenge, and this is something I usually do for myself. I say, what would it be like if I tried to do this? If I want this, how would I do it? So the first idea I had, or one of the ideas of this project, is I wanted to make a movable robot figure out of cardboard, and that's this guy. He's actually known on the internet as a Danbo. He was created by a Japanese designer out of cardboard boxes. So the idea is that you have a cardboard box, and he looks kind of cute, and he can move around, and he created this character called the Danbo. Now, to make it, I had to figure out a system to make cardboard joints joints out of cardboard. Now, this was a really important thing because I've seen them before. I've seen Danbos, but they usually make them out of plastic, and plastic has a certain specification for how you produce it and so on. But I thought if the character's cardboard, I should try to keep true to that and see if I can't make all the pieces out of cardboard. And I work pretty much exclusively in cardboard anyway. So it really sort of spoke to me in terms of how I thought I could make something. And it was an interesting challenge. So can I make things completely out of cardboard? And knowing that cardboard is not that strong a material, I mean, it has a certain integrity to it, but it's not, as strong as, let's say, wood or plastic. But it's cheap, and it's recyclable, at least the stuff I use is. Okay, so basically I refined the problem down to a one thing, which was the most important part: how to make a hinge that works in two axes, that articulates itself in two axes out of cardboard. So there were a few other things I wanted to do, so once I understood that that was the problem, I thought I want to also make it have as few pieces as possible and to the smallest effective scale. So I wanted to also make it small. I also wanted it to be assemblable without too much difficulty or time. That is, you should be able to assemble one part of it within a reasonable amount of time. And that the pieces are then robust enough that I can use them over a period of time and that they'll last. So my first instinct was to look up on the internet and see if this had already been a solution to this, but it yielded almost nothing. And what I find is that in my goals, they're often so specific that when I ask a question like, how do you make a cardboard hinge? No one else has ever thought of that problem, and it seems so improbable that the solution, a solution would be so improbable that no one else would think it was a problem that needed solving. And so when I find this, and I find no real answer on the internet, then I kind of think I'm on the right track, because if nobody else has asked the question and nobody else has come up with a solution, then I'm doing something that I think is effectively new, breaking new ground and asking questions that other people may not necessarily be asking. So my next step is to develop something which works without much concern for size or difficulty. So I take my set of goals that I have, and I try and refine them down to what's the bare necessity to get the first iteration of it. So I didn't think about size so much, and I didn't think about how difficult it would be to assemble. And this took some thought and some sketching and a few attempts to come up with an idea. And in the end, this is the result I came up with. And I'm going to put down the mic for a sec. So you can see that here's a flexible hinge. It takes about, I think, somewhere around 25 and 30 pieces to make. And it rotates only in one axis. So let's say this is attached to the arm of something. I could only move it like this in one axis. But it sort of solved the problem that I wanted to solve and took me to the first stage. And in the end, this is the little Danbo that was made from it, and I'll show you that too. I'll put down the mic again. So here's the character, and each one of his parts is a hinge. This hinge only moves in one direction, but this one can move this way, and it can also rotate. So you have an arm that can do basically everything and go everywhere that an arm can go. And the same hinge is effectively for the head. So the head can rotate, and he can move up and down. So he can say yes, and he can say no. And that adds to a degree of character to him, the ability to say yes and no. And this is a piece for all the different 5 hinges out of one sheet, because I also try to work to the efficiency of my material. And I could just fit exactly enough for 5 pieces, 5 different hinges in, and then assemble it. And the assembly was relatively complex. I think it takes me about, if I was going to make it out of this, it would take me about, for one hinge, probably about 20 minutes or something to just assemble it. And that's me already knowing well how to put it together. Right, so I went through this process a few times, and I thought about it. So after a few weeks of trying many different variations, I came up with a much better solution, which achieved all of my goals. And it ended up looking like this. Let me see, I can grab the example. This. So you can see it's a lot smaller, and it's only made out of 8 pieces. So effectively, by doing the process, and it does one more thing, which is it not only rotates like this, but it also rotates in the other direction. So you can see if this is the wall, the arm of the object can move this way, and you actually kind of have to get up close to see it, but you can see it also will rotate like this. The example, of course, is the tiny guy. So here's his arm. It rotates up and down, and back to front. So he moves in, again, in direction. But the really interesting part was that it all happens from one piece. This piece needed a little rotator to make it work that I had to then work into the design. And this one I don't need that for. It's just a simple piece that I can assemble and requires a little bit of clever putting together and so on. But with only 8 pieces rather than 30, it was a real step forward. And it was also a lot more quick. It was a lot quicker to make. I can make it in a minute, for example, as opposed to 15 or 20 minutes for each piece. Right. So it's quicker. I can iterate the ideas more often. I can cut. I can cut it. I can just make it effectively a lot faster. So oh, wait a sec. There's one more thing I want to show you. And this is where that large one was 5 hinges. This is 6. So you get an idea of scale. I scaled it down by, I don't know, probably something like a fifth to the amount of material, and also to the size, something like that. So you can get an idea of how much more efficient it is. So I went through this process many times, and I've done this with a lot of different projects. This is just one example. And what I've learned is that I really appreciate using a laser cutter. One of the things that the laser cutter allows me to do is work quickly, so it's very fast, which means I can iterate very quickly and test my ideas. It cuts a variety of materials, unlike something like a 3D printer, which I have nothing against, but just that I find it really slow, and I'm not sure that I want to make everything out of plastic. I like using recycled materials, and that uses less of. I like the idea of having my material and then just cutting it and making it the thing I want. And it's relatively fast and clean, especially with cardboard, so my material of choice. It also uses some standard formats in software and so on, so I can prepare my tests ahead of time and not waste valuable time in front of the machine. I think this is also important for a lot of people because if they want to do 3D design, there's a whole learning curve that has to happen when you want to design things in 3D. Those processes get easier and easier over time, but it just tends to be that people can work more easily in 2D. And a lot of my things end up being 3D, but they start with a 2D environment. I mean, I also model in 3D, that's not a problem, but I think that's also what allows me to say the difference between the two can be a big difference in terms of how you have to learn things and how you have to conceive of them. Another thing to mention is that working with cardboard means that I can translate my ideas relatively easy into other materials. So if I start with cardboard, if it's strong enough to work in cardboard, then I can relatively easily, and it's pretty definitely strong enough to work in wood, for example. Wood just has more integrity, and it cuts very similarly. I mean, effectively, cardboard is just pulped wood. And the same is true with plastics and metals and so on. They tend to have more tensile strength, but they're also more expensive and then more precious, etc. So the advantage of that is that because my materials are effectively cheap or free, because I take a lot of cardboard that I just take out of the garbage, or when I say garbage, I don't mean like the slimy orange peel stuff. I mean, things that are thrown away at the back of a shop that are all nicely cut up and so on. Or even at Makerversity, I've taken a bunch from there. And I find I tend to be less precious with it. And therefore I can test and iterate a lot more. So if I'm not as precious about my materials that I don't think I'm wasting it, I'm more likely to try and test things out and see how I can make them work. Whereas if you're working with a very expensive material, even comparatively wood is much more expensive, then I think I would be willing to take less risk and therefore maybe learn less and therefore come not quite as far. Okay, well, that's pretty much it. To sum up, in the process of helping people figuring out how to make stuff, I try to get them to do a few things. So this is maybe something to do. Yeah, I won't even take 5 minutes. So I call this sort of constantly questioning and constantly imagining, which are sort of general idea terms, but what I mean by that is to get people to focus on a few basic principles. One that I think is perhaps the most important is your object goal, and that is a bit of the metaphor of the chair that I described before. Physically, try and think of what it is you want to make and what you want it to do. Define this as clearly as possible. So if you have something that you want to work in a specific way, the clearer you think about it, the easier it is to try and achieve that. It's not to say that you can't change that idea, but it's important to have some degree of clarity when you want to make something. You also want to think of what the end material is. What materials you have, what's available, what forces does it need to withstand, etc. So what is it you're trying to build to? I've thought about building chairs out of cardboard. but I think, the weight of a human being, I'm sure it's possible, but I imagine that it might not be robust enough over time to be able to do it. I've seen furniture built out of cardboard, but I don't necessarily trust it to do the thing I want. Maybe I'll carry that forward and change my mind about that, but because I know the nature of the material, I also think that it might not be the right material for that. I would maybe try and build a model in cardboard and then perhaps translate that into wood or something like that, because wood material just tends to be stronger and more robust. So your object goal, your end material, the process. So what I mean by this is sort of paper to computer. So the idea that you have something that you sketched out as sort of a general drawing, and then how you work the 3D software, the CAD, Photoshop, Illustrator, etc., and how you translate that to a machine. Like how you go from your drawing and your idea, your concept, whatever you think that sketch is, and turn it into something that a machine can understand. How do you make that step can be quite important. And maybe even more important than anything else, because I see that software is not really the be-all, end-all of how you work something. I mean, people quite often expect software to do everything for you. But what I've discovered is that's really not the case. You quite often have to adjust things you want to do to be able to use the software well. And this is especially true of our laser cutter because it uses Chinese software that it doesn't really speak English very well, and it's pretty buggy so that you always get errors imported, and you have to then look for the errors, and there are ways of preventing the errors from coming, at least as many as would come if you're not careful, and if you do things that are more complex, there tend to be more errors, and it just becomes a cycle for, all right, now that I know this is going to happen, how do I anticipate that and prepare my design to minimize it effectively? Efficiency, very important. Am I using my time and materials efficiently? And so then what preparation do you need? It goes back a little bit to what do you need to do before you need to do the other thing. So when I work efficiently, I want there to be very little space between this. I want to be able to fit all my things into the smallest space that I can. Even though this material is effectively free for me, I still cannot bring myself to waste it. So I want it to fit within a nice, neat package that everything is compact enough. I can still have it as one piece, but then punch it out and use it as I need it. And that's true within a lot of things. And it also works with software and also your goals, what you're trying to achieve. And the last thing is iteration. And if you're working efficiently, then you will have more time to iterate and experiment. And that works also to the kind of materials you choose, but also then the idea that you will iterate, that you don't just start with an end idea of the thing and make it too concrete that you can't take some time or some thought experiment or some ability to then take it some way further. That's effectively the main goals. Object goal, end material, process, efficiency, and iteration. Those are the things that I think are worth thinking about in terms of getting an end project. And I guess that's it. That's pretty much it. If you guys have questions, feel free to ask, and I'll answer them my best I can. And if you don't want to do it here, feel free to come over to Makerversity. I'm on the first floor. Psychiatrist is in. So, any questions? Yeah? Should I give them the microphone? No, okay. Well, what's your question? You, go ahead. Oh, that's a good question. How to know when to abandon a project. I don't think I ever really abandon projects, but I guess I'm a sort of a pack rat of ideas. So what I do is I just file them away to somewhere where at some point in the future I may be able to find them and dig them up again. I guess abandoning for me is just a time period. You just leave it and so on. I mean, do you have a specific idea in mind that you would like to abandon or that you want to keep going? I understand that, and I guess I don't really, I mean, I do have things like that. For example, I was trying to make a foldable Frisbee, right? And I worked on that at pretty much the same time I was doing that. I mean, I like Frisbee, and I like the idea of doing aerodynamics and so on. And I kept trying to use a certain material. I kept trying to use this material, and it wasn't folding properly. And I kept trying to iterate it and try different things, and it just wasn't working. And then I thought, well, wait a sec, maybe I should try it out of the cheaper, more flexible cardboard, and see if I can't design the same thing. And when I tried that and pretty much used the same pattern, it just folded a lot better. And I realized, actually, I should have been doing that all the time. So I don't think I ever really abandoned it, but I kind of took time periods off from it to let my brain sort of settle and do it. Yeah, I don't think I really abandoned things. Maybe they just sort of sit in the back of my memory somewhere or something like that. Or maybe I just forget about them. That's the way I abandon them. And they just sort of fade into the background. But I can't really think of knowing when to abandon it. Maybe the idea of abandoning something would happen when you really don't have any more inspiration to keep going, you know. It depends on the kind of problem you're trying to solve too. So I like to give myself difficult problems. So they'd be relatively easy to abandon because, like I said, I mean, no one told me that I should try to make a hinge that works in 2 axes, and I didn't find anything that did that. And it could easily have been like, oh, okay, this is too difficult, I'm just going to leave it. But I'm a bit of a bulldog, so if I come up with an idea and I think, well, there's got to be a way to solve it, then I'll just hold on until I actually solve it. And if it's a really interesting problem and a difficult problem, I'll probably try harder. And so, yeah, so I wouldn't abandon it. I think the only things I'd really abandon are things I didn't care that much about. So then it would be like, yeah, this seems sort of banal, like, you know, how to make another copy of this thing that everybody's already done. Then it would be less interesting, and therefore I might. But that's the only thing I would think that I would ever want to abandon, really. Cheers. Yes, sorry, go ahead. Yeah, I do. I always start with a prototype. So, go ahead. Yeah. Right. Well, I think keeping an open mind to that, but can you give me an example of what it is that you're trying to prototype? Okay. Okay. Yeah, I see. I can identify with that, especially with the thing I just said about like trying to make a foldable frisbee. I had this idea to hold on to something that I was using, and I held pretty steadfastly. I think at least through the first 20 iterations or something like that, and that was too many. I mean, that happened over a course of a couple of weeks, and I didn't do it constantly. But when I realized that I should have been trying something else, you know, I sort of looked back and said, "Wow, that it's a bit of wasted time." It's also a learning process, but I just think of it for next time. So if I was going to do that again, I might try the same iteration over a bunch of different materials. It depends what. I mean, if you're building in something that's really expensive and hard to work, then of course that's a lot more difficult. But I would try with something that's cheap and again allows you to iterate quickly and easily, and then work from that to something that's more complex. What kind of material were you working in? PLA, yeah. Okay. Yeah. That you can't do anything with. Hopefully you could find something else to do with it. But I identify. But again, see, that's the thing. I try to do it in something where I can test my idea where I'm really not too heavily invested. I think that's the advice I would give. But if you want to discuss it further, I'm totally happy. If you haven't already solved the problem, feel free to come over to Makerversity. I've got a chair and a little booth. It looks like a bit like a lemonade stand. So you can come and have some ideastic lemonade. And I guess that's it. All right. Thanks a lot for listening. Appreciate it. Cheers.